Hello everyone, welcome to Module 1 Part 1 of the course CS365 Optimization Technique, Decision Theory. Decision making is a daily activity for any human being. There is no exception about that. For example, getting out of the bed in the morning, selecting a school, college, or even selecting dress for a party, we have to decide. So what is decision? It is defined as act of selection by decision maker from among several available options considering to be the best of some pre-assigned standard. Decision theory is the study of a decision maker's choice. Decision theory is concerned with reasoning underlying a decision maker's choice between taking a bus or getting a taxi, or more far-reaching choice about whether to pursue a demanding political career. Irrespective of the type of decision model, there are certain essential elements which are common to all. Firstly, a decision maker who is going to take decisions. Secondly, a decision is made from among a set of defined alternative courses of action, which is also known as strategies, acts, etc. Thirdly, consequences of any course are dependent upon certain factors beyond the control of decision maker, which are called states of nature. Finally, it is possible to quantify each outcome for each course of action chosen by decision maker. A non-payoff will result with conditional on which states of nature has occurred. Decision-making process involves certain important steps. First, we have to define what exactly is the problem. For example, you want to pursue a particular course. Secondly, list all the options. For example, listing all the colleges providing that particular course. Thirdly, identify all possible consequences. For example, whether the college are providing scholarships, hostel facility, fee structure, etc. Fourthly, list the payoff of each alternatives with respect to the states of nature. For example, expenses incurred for that course in that particular college. Finally, select a mathematical model, apply it, and make your decision. A tabular arrangement of payoff values is known as payoff matrix. The role of payoff is to summarize pros and cons of decision in a tabular form. For example, here in this table, our options are to stay indoors or outdoors, and states of nature are rain or no rain. If you are outside and it's raining, it would be a disaster compared to no rain, which would be a real comfort. If you are staying indoors and if it is raining, you may have mild discomfort because you cannot go outside, yet happy since you are not wet. While if it is not raining, you are still indoors, you may have regrets for not going outside. Hence, this disaster, real comfort, discomfort, and happy and regret form a payoff matrix. This is a general form of payoff matrix. Need not to be unique since you can write courses of actions vertically and states of nature horizontally. Decisions are made upon the information of data available about the occurrence of an event as well as the decision environment. There are namely four types of decision environment. First, decision making under uncertainty. The decision maker knows with certainty the consequence of every alternative for decision. The decision maker knows with certainty the consequences of every alternative or decision. It is very difficult to find complete certainty in most of the decisions. Secondly, decision making under uncertainty, in which decision makers has no idea about possibilities of various outcomes. For example, demand of the product in a company, moves of the competitor, etc. Thirdly, decision making under risk, in which decision maker has adequate information to assign probability to the happening or non-happening of each possible events. For example, tossing a coin, rise and fall in the share markets, or either in other words, bull and bear in share markets. Finally, decision making under conflict, in which decision makers are not sure about states of nature, for example, in conflict or in a cricket match. This figure shows decision making under risk is some part of decision making under certainty and decision making under uncertainty. Since decision makers knows or aware of consequences of each course of action with certainty, that person would focus on the corresponding column in the payoff table and chooses a course on action with optimal payoff. For example, buying a new carpet, installing a new equipment, promoting of an employee. Here is an example showing the alternatives such as small, medium and large facilities, like low, moderate, high. Possible future demand is the states of nature. From this table, we can see that for low demand, small facilities gives maximum payoff. For the moderate demand, then medium facilities give maximum payoff, while for high demand, the large facility gives maximum payoff. Here we are certain that each type of alternative we have to choose depending upon the future demands. Decision making under uncertainty. Here decision maker cannot predict with complete confidence what outcomes of their action will be. For example, launching a new product, changing marketing strategy, and economic shift. This lack of information led to development of in MAXIMAX criterion, also known as optimistic criteria, here the decision maker locates the maximum payoff for each possible course of action. The maximum of these payoffs is identified and corresponding alternative is selected. Here, maximum payoff corresponding to A1 is 27, maximum payoff for A2 is 35, and maximum payoff for A3 is 52. The maximum of maximum payoffs here is 52, hence the optimal alternative is A3. This criterion is known as pessimist criterion, since decision makers locate the minimum payoff for each possible course of action and maximum of minimum payoff is identified. In this table, minimum payoff of A1 is 12, minimum payoff of A2 is 17, and minimum payoff of A3 is 15. Since 17 is maximum among these minimum payoffs, the alternative A2 is selected. Regret criterion, which is also known as savage criterion. It is defined as difference between the best payoffs we could have realized and the realized payoff. This difference, which measures the magnitude of loss incurred by not selecting the best alternative, is known as opportunity loss, or you can call it as an opportunity cost. To develop regret metrics, find the best payoff corresponding to each states of nature and subtract to all other entries. From this table, in the column of the states of nature S1, 52 is the maximum. Hence, subtract 27 from 52, 45 from 52, and 52 from 52. Do the same for other columns and we find the regret matrix. For each alternative, find the worst maximum regret value. From the table, for the alternative, A1 has maximum regret 25, A2 has the maximum regret 19, and for A3 the maximum regret is 11. Among these regrets, 11 is the minimum. Hence, A3 is the best option. Laplace criterion is based on the insufficient reasons. Here we compute the average payoff for each alternative. For the given table, the average value corresponding to A1 is 19.75 and A2 is 29.25 and A3 is 33. Among these averages, 33 is maximum. Hence, the alternative A3 is the best option. HURWICZ criterion is defined to reflect the decision maker's attitude ranging from most optimistic to most pessimistic. Here, the alpha is known as the index of optimism or pessimism of the decision maker, which takes the value between 0 and 1. Let the index of optimism alpha is 0.7 for this table. Since 27 is the maximum payoff and 12 is the minimum payoff, the weighted average is 27 multiplied by 0.7 plus 12 multiplied by 0.3 equal to 22.5, which means 0.7 is the rate of optimism and 0.3 is the rate of pessimism. Similarly, the weighted average for each A2 and A3 is calculated. So, hence, the weighted average for A2 is 36.6 and A3 is 40.9. Since 40.9 is maximum, hence A3 is the best option. Under condition of risk, the payoff associated with each decision or alternative are described by probability distribution. For this reason, in this environment, decisions are based on expected value criterion, also known as Bayesian decision criterion. Let us take an example. Suppose you want to invest $10,000 in a stock market by buying the shares in one of the two companies A and B. Shares in company A could yield a 50% of return on investment during the next year if the market condition is favorable. Otherwise, it may lose 20% of its value. Company B provides safe investment with 15% of return in favorable condition and 5% in unfavorable condition. Company B provides safe investment with 15% return in favorable condition and 5% in unfavorable condition. These are favorable and unfavorable condition in market is also known as bull and bear market. There is a chance of 60% of bull and 40% of bear market. The decision problem can be expressed as the following payoff matrix. This figure represents the decision tree of the stock market problem. The square represents the decision point and the circle represents a chance event. From the figure, we can calculate the expected return. For the stock A, the expected return is $2,200, while for B is $1,100. Hence, the expected return is the best for stock A. That means it's better to invest in stock A. So this is the end of the part 1 of module 1. Thank you.